Welcome to the latest episode of the MFG Radio Network's Lunch and Learn, as we highlight some of the latest advances in manufacturing and design, gain insights about the newest products and technologies to move your manufacturing ahead of the competition. I once again am Jake Kaufman, a managing editor for today's medical developments, aerospace manufacturing and design, defense and munitions, and EV design and manufacturing. Today we are joined by SMW Autoblok as they will discuss electronics and automation for the next millennium with inductive couplers for power and data transmission, electric and pneumatic grippers, and electric intelligent work holding. Now, SMW Autoblok is a work holding company focused on achieving customers' goals and expectations with the highest quality products and services. SMW Autoblok combines stocked standard products with a highly trained sales service and engineering team to consistently provide the ideal work holding solutions for customers across a wide variety of industries. Now, the organization strives to achieve deeper understanding of customer needs, provide products and services geared towards specific customer applications, maintaining long-term mutually beneficial partnerships to enhance machine tools and drive modern manufacturing. Now, today's presenter is Larry Robbins. He joins us as the president of the commercial division of SMW Autoblok. Larry joined SMW Autoblok in 2007 as the national sales manager and recently was appointed the president in 2019. As president of SMW Autoblok's commercial division, Larry is responsible for all strategic sales and marketing initiatives, as well as overseeing SMW Autoblok's North America sales team and customer base, including machine tool dealers and OEMs. He also oversees various projects internationally. He has more than 35 years of experience in machine tool manufacturing. And prior to working for SMW Autoblok, he owned a successful manufacturer's rep company for 13 years. Larry's expertise in the machining industry began in his early youth when he worked side by side his father, who owned a prosperous distributorship in New York. So, Mr. Robbins, the floor is yours.
Thanks, Jake. As always, it's a pleasure. I'll apologize up front. I have kind of a cold, so my voice, this accent isn't bad enough for you poor people. Now you get it with a cold. Just to give you a little heads up, SMW Autoblok has been in business since 1942, and SMW Autoblok is best known for its work holding components and chucks in particular. We've been a chuck company since day one. We were a specialty work holding manufacturer, and over the years, we've developed our products to adapt to the next generation of manufacturing, next generation of work holding, all the way up to now, incorporating electronics and electronic monitoring into work holding. That is going to be industry changing. I've likened it to the difference between operating a Bridgeport or a 5-axis machine tool with today's technology. Just to start, I'm going to share with you a very brief video just to give you an idea of the technology and the basis of the technology that we're talking about. We've developed a product or a solution that allows us to transfer power, data, and information wirelessly. This allows for a few different advantages. The fact that you can have contact-free transmission of energy and data via an air gap gives you some opportunities to provide information and data that in the past, or give your feedback in real time. What you're looking at here is a very basic setup. You have a stationary side, a mobile side, and this just gives you an idea of how it starts. The stationary side, of course, has a control unit that interfaces to the machine tool control, so you have full integration. We have an inductive coupler. One unit is always stationary. And again, there's a lot of different backups, safeties, interrelated items that allow for a very safe, very secure application. The beauty is large transmission distance is a state of mind. It's anywhere from 1 millimeter up to 6 millimeters, which is a large gap. It can transmit through any material that is non-metallic. The mobile units do not have to be stationary. They can be on an angle. They can measure movement. They can measure force. They can measure temperature. They can measure position. It's kind of limitless what you can do with this technology. The reason I start out with this part of the presentation is just to give you an idea of the intricacies that have been developed. The development of this started in 2009. When we first introduced this to the market, it was a much different system. It was a fully contained unit that was controlled by a tablet. As you can see by the demonstration, the signal quality is not interrupted by vibration, misalignment. They're wear-free and maintenance-free. You can transmit through non-metallic obstacles. And the beauty is, because you have simultaneous data and energy transfer, it gives you the ability to energize a component sometimes outside of your manufacturing environment. And once it's in the environment, all you need is 24 volts to monitor continuously the different operations. Up to 8 digital signals are transferable on a small style unit. On our larger units, we can go up to 16 transfers of information or power data from a single unit. We offer a large range of products and up to customized solutions. We do not look at things from the standpoint of it has to be standard. We realize that every application is a little bit different. And with that being said, it just gave you a little bit of background and information on where we're coming from and where we're going to with this technology. With that being said, there's a lot of different ways to utilize this technology. It can be in, I know we're specifically talking about aerospace from the standpoint of the amount of reporting that's necessary, the amount of data collection that's necessary, especially because of the components that are going into either a commercial aircraft, a civilian aircraft, space, as Dan mentioned. It's becoming a very large part of what we do. It also allows for the monitoring of other operations. It doesn't have to be specific to manufacturing. If you have specific componentry that you have to identify by part going to a specific fixture, going into a specific operation, into a specific machine, that can all be controlled with putting these sensors into your componentry. So I can take even a manual fixture, have a sensor built into the fixture end, have a mobile stationary unit that it passes by, collects the data, makes sure it's the right part in the right fixture, going into the right machine. You can actually have a trigger that auto downloads a program, auto downloads your quality information, auto downloads your all of your probing information, everything, and backloads all the information to a reportable style data outlay that's customer definable. Most of these projects will require R&D between us and the customer or us and the OEM. There is a specific buy-in or a specific requirement on the OEM side when you're integrating this into a machine tool. We have to integrate through a control box with a PLC that we provide. The integration is generally done between us and an integrator and a machine tool manufacturer. And it allows for accurate, repeatable, very predictable monitoring of your manufacturing conditions and your part conditions. It doesn't just have to be, again, for part manufacturing. You may have componentry that comes in as secondary operations or a part that's being heat treated and then added to the componentry later. Even parts that come off of a production line, you may have temperature requirements as you get down this production line. You can actually have temperature monitoring and it can stall the monitoring or stall the movement of this component to match what the component's needs are once it gets to the assembly area. The next slides I'm going to share with you are just a basic idea of how we go to market, what we do, just some of the different ways you can use or utilize this from a work holding standpoint. Coming from a work holding background, the natural integration for us was in work holding for multiple different industries. You'll see as we move forward, there are some examples that have nothing to do with machine tools or manufacturing as we think of it. But just to give you an idea, again, SMW Autoblok is a work holding company. So with that being said, this product was designed by our one of our German manufacturing facilities. The technology is ours. It was developed internally with a team. The company that was making this for us in the past, we actually purchased the intellectual knowledge for we own our own intellectual knowledge, and we have it processed by a large electronics manufacturing firm, and we also manufacture internally. The beauty of the way this works is, excuse me, I jumped ahead a little bit. We make it available to monitor standard hydraulic setups, hydraulic hybrid digit setups, which are hydraulic setups with electronic monitoring built in. Electronic digit, which is or electric digit, which is a electrical signal sent to power the unit and monitor movement and things like that. And electric flex, which is just another venture into that. We make it available in multiple different ways, from a small M12 by 1, M18 or M30 compatible mounting of a proximity style switch. And as we think of proc switches in the past, you had a disc, you had a switch, and there was a very short spectrum that you had to locate within in order to get a green light to move forward. With this, the band is adjustable. We can transmit over a distance of up to 2.5 millimeters. It's 24 volt or 1 watt. We can transmit 2 digital signals from our smallest unit. We can offer inverse polarity protection, short circuit proof. They're IP67 protected. You go from this to a larger unit with it's 180 millimeter diameter. It's 24 to 48 volt. Transmission distance is up to 6 millimeters, so just over a quarter of an inch. You can transmit energy up to 250 watts. We can transmit that either by Ethernet, EtherCAT, Profinet, Profibus. These are all IP67 protected, which means they can be submersible. Same as we showed you in our example, you have a base unit, you have a receiving unit, and the base unit is stationary. The receiving unit is part of either a moving component or a traveling component, and it allows you to monitor. We make them with through holes, we make them with closed centers. And as you see, as we go through, it's a variety of different componentry, and the larger the component gets, the more power you can produce, all the way up to 1,500 watts or 1.5 kilowatts of power can be transferred, again, wirelessly. So your wired components are stationary. Even the mobile wireless units are wired into the component itself, but with no wires connecting the two. So envision being able to now power a chuck or a swing clamp or a vise or any other component that needs power to go to it, but taking the hydraulics out of it. And I'll explain that as we go forward. The first example I'm going to give you is with a hydraulic setup. It's nothing more. It's a 4-jaw, 2+2 style chuck, which means basically jaws travel in pairs. It gives you the ability to adapt to odd shaped parts, which in aerospace and space is very standard, out of shape, out of round, odd shaped components. Using standard top tooling, we allow a customer to adapt to their tools or their specific application using standard top tooling, where in the past they would have to have special work holdings, special jaws, special fixturing, whatever the case may be. With this, you have a base pallet that mounts to a pancake cylinder that energizes the chuck, and it's all powered still by hydraulics. But what we have built into this system is the ability to monitor our pneumatic, our hydraulic, and our part sensing presence capabilities, as well as pallet seating and part clamp conformation, part position, jaw position, grip force at the same time can all be monitored while the part is still operating. The beauty of these systems is the hydraulic cylinders are flat into the chuck body and not in the Z-axis, so you don't get any added height, no added weight. So you get to maintain your entire Z-axis, which is very valuable. The hydraulic cylinders are an integral component to these chucks, and it gives you the ability to have, again, 2+2 actuation using a standard stroking cylinder or a standard stroking pallet. This gives you an idea of having the hydraulic valve connection to the machine to maintain the pressure. Hydraulic accumulators are built in. We entered couplers for signals and powers for sensors, which allows for monitoring of jaw position, grip force, and clamp pressure on the part itself. Pressure sensors allow you to monitor conditions of clamping and or part condition so you don't distort your part during manufacturing. We offer linear stroke control built in and measuring the end position of jaw stroke, which gives you predictable, repeatable setups, predictable, repeatable grip forces. So once you ascertain what the perfect conditions are for your part, you can repeat those over and over again without having to constantly recreate the wheel. We've also applied this to a vice setup, and we've taken it a step further. We have linear positioning. We have the ability to monitor through our wireless technology. We have quick jaw change top tooling. The quick change top tooling actually can be robotically changed just by moving a pin from a lock to an unlock position with a robotic hand. As time goes on, I think you're going to see that the stationary hydraulic and hybrid digit technology is already being accepted into our industry now. You're starting to see it accepted into aerospace. You're starting to see it accepted into forgings, castings, automotive manufacturing, transmissions, oil and gas, the mold and die. The applications are limitless, and they're not just applicable to machine tools. Envision this. Envision you make a product that has multiple components. And throughout this process, I've gotten an education as well as everyone else involved. The beauty of this componentry is it's adaptable to anything. So if you have a product that has multiple complements or implements that mount to the machine, so you might have 6 different tools that all look very similar, but using the sensor technology, you're sure that every time you're implementing the right component for the right process, for the right operation, so you don't have reworks, remanufacturing. Envision high-low clamping without a high-low cylinder. Envision being able to offset jaw positions within the physical limitations of a chuck. Individually and in separate axes, when you get into the fully electronic work holding that we're providing or that we've invented and manufacture, you now have the ability to program each jaw or move each jaw independently of the other. So if I'm doing a variety of castings or forgings, whether it's on a vise, a chuck, a clamp, a fixture, it doesn't matter. As long as I have the ability to monitor. The other thing we've built into every one of these systems is they're fully sealed. And the fully sealing serves a lot of purposes. First of all, it keeps coolant and swarf out of the component itself. So it decreases the impact of coolant and chips on the internal operation of any of our work holdings that we're discussing right now. All of our new developments are sealed work holding. One of the last things that has hydraulics on a machine tool are chucks. Everything else at this point basically is either servo driven, electrically actuated. There's a lot of different ways to skin the same cat. But with that being said, the last basic holdout for hydraulics is work holding. And I think that's going to change as time goes on with this new technology. As I discussed before, here's an example of a manual fixture. Just holding shafts, output shafts on our power vise setups, on a double angle style setup. This actually happens to be a single-sided setup. And all we're using the sensor for is to identify the correct fixture is going into the correct machine with the correct parts for that process. We have fully electric long stroke and standard stroke vices. The first question we generally get asked, well, this is all great, but what about grip force? I would challenge anybody to come up with a hydraulic unit that doesn't apply the same amount of grip force or a similar percentage of grip force. I mean, you're talking 40 kilonewtons of grip force on a vise this size is 9,000 pounds of gripping force or 900 pounds of friction force. So I can grip a part across a large spectrum, and I can vary that pressure in 1 kilonewton, actually 0.1 kilonewton increments across the whole spectrum. Because I have stroke control, I do not have to open or close my component the whole way, or open all the way or close all the way, and waste valuable manufacturing time in just watching components open and close. I can now predict, okay, I need to load this, I'm robotically loading this, so I need to open 25 thousandths larger than the part. So if my part is 4 inches, I will open 4.025, load my part. Now, instead of waiting for the 9 inches of travel to come to the center, I now have that in a predictable environment, so I can not waste any time with process. Same idea. Everybody's, setup production has been the buzzword since the 70s and 80s, really got popular in the 90s. The 2000s setup production was kind of a requirement, a basic requirement. This takes it to the next level. If you look at all the 0-point systems out there, whether it be palletized, part changing, whatever the case may be, it gives you the ability to mount a series of these on a table, and either put a pin in a part or a pin in a fixture and have repeatable setups. So if I go from a vise to a chuck to a fixture back to a vise on a machining center or a 5-axis machine, I'm going to repeat my position within 5 microns, guaranteed every single time utilizing this technology. We've taken it to the next level. We make a pneumatic version, which is spring to close, air to open. We make a fully mechanical version. And then we make a fully electric version. The electric version offers a few very, very unique features. It gives part sensing. It gives air blow off. It gives the ability to orient your parts and have a clocking mechanism built into the system. The beauty of the way our system is designed is every other system on the market requires you to very gingerly put your pin or your receiving component into the unit. So you have a male and a female. The male part has to go as level as it can. With ours, we can go up to a 23-degree angle and still have repeatable, accurate work holding. As I said before, the beauty of this technology, having independent axes, now envision taking a fully electric chuck or mill turn electric flex. And we have the ability now to have 4 independent NC axes. So in the event that I was making 5,000 castings or forgings, and I'm holding an iPhone in my hand, very bad example, and for the lack of having a part in a hotel room, if I had 5,000 of these, and from my first to my last, there was a 20 thousandths variation. As long as I'm within the physical limitations of my work holding component, I can probe my part and say, okay, at 273 degrees, I am off by 20 thousandths. Sends a signal to the machine sends a signal to the unit, and it'll offset the part at 273 degrees, 20 thousandths. So in the past, we would have probed the casting, we would have manufactured a part, we would have probed the part, found out the part was out of spec, and either scrapped it or had to remanufacture. I alleviate that up front, or we alleviate that up front by probing the part, offsetting the casting or forging, or the raw part, and proceeding to manufacture a good part. You'll also notice we're doing round parts, square parts, mushroom-shaped parts, thin wall rings, fabrications, or rectangular parts. They don't have to be consistent size, shape. These are all utilizing existing standard top tooling. The beauty is we've now taken this to the next level. We had taken where we can now monitor jaw position, jaw pressure. In the past, with a high-low clamping package, we're one of the few companies that made a true high-low clamping package with a cylinder and a control unit that allow you to never release the component while you went from high to low or low to high. If you were going from high to low, you always had to stop the spindle, go from high to low, you dwelled for 2 seconds. It literally was a 2-second process. So as the spindle was slowing down and coming to a brake position, your tool was changing. I'm reducing my grip force without ever releasing my part. And at the same time, giving the customer the ability to have predictable, repeatable process. The problem has been over the past is auto loading op-10 parts because you're as machined or rough castings or forgings. There was no way to sense without using buttons or in non-exacting location of parts. You knew the part was in position, but you didn't know if it was tilted. You didn't know if it was exactly in position it was supposed to be in. We've developed a whole line of electronic locators. These electrically adjustable, adaptable locators allow you to set a tolerance band for your parts. You'll notice there's a monitoring light on every indicator component. And now, because I can adjust the sensing technology, I can go from 0.1 microns all the way up to, I believe, 5 microns of surface irregularity. I can now have OP10 parts presence sensing for robotic loading and know I'm in the right position. I'm sitting on the right component. I'm clamping in the right position, and my part is clocked in the exact direction it's supposed to be in without any human intervention. We've also applied this same technology across the board to what we call our RTE motion. It gives you 8 independent electrical drives installed on one tombstone face, or each tombstone face, excuse me, total. It allows you to control each one of these independently or all simultaneously. And let's face it, when you're loading with a robot, unless you have 8 robots loading a machine, no one's loading more than one part at a time. So the ability to have independently adjustable or independently controllable units allows you to safely, accurately, and repeatably load your parts in a tombstone style setup, a two-sided tombstone setup, whatever the setup is that works for your system. Each drive can be actuated and controlled, like I said, independently for stroke and force control. All the safety features are integrated, such as force and stroke monitoring. If you have other things you would like to monitor, we can do that, again, through research and development with your department internally. We start out, we've developed this now. This technology goes down to a smallest diameter now is 320 millimeters. We go from 320 millimeters now up to a 1800 millimeter diameter. I believe in the future it will go smaller and larger. I don't see it going much over 2 meters because there's really no need to monitor something that large unless you're doing large aerospace components, and then we see that need. But you'll see even the chuck has the LED displays on the face, so you know that your jaws are clamping on your parts are touching your jaws, your parts are touching your locators, and you get that visual confirmation at the same time. So basically what the aim of this is to take hydraulics out. So there's 0% hydraulics, 100% electric, 100% performance. And when we say 100% performance, you know, that's kind of an oxymoron. As long as your people understand the ability to, every part can be set up on a setup station outside your machine. You can use manufacturing time for just that manufacturing time. You can actually inspect your parts outside the machine. We can take this, and this is applicable across a broad spectrum. So now I can take the same componentry I'm monitoring on my manufacturing side. I can take it to my warehousing side. I can take it to my inspection side. I can shelve a part with a part in the fixture or in the chuck, pull that off a shelf a year later. It'll go through a 25 millisecond test, and it'll just make sure that the grip force is consistent, the part is in the right position, and allows you to proceed and know that you're safe with the customer safety at, you know, as the optimum. Again, just gives you an idea of the componentry itself. The smallest diameter, again, is 320 millimeters, 100 kilonewtons of grip force, up to 100 kilonewtons of grip force, 3,000 RPM spindle speed, 4.5 millimeters of jaw stroke, which is large, 5 micron repeatability. I mean, you're talking 2.5 tenths. So reality is we can build the full grip force in up to full grip force in a second, full jaw stroke with no load in 3 seconds. So it's very quick actuations. Again, just to give you, you know, that we will review the same thing with clamping profiles. You can be 4-jaw self-centering, 4-jaw compensating, high-low grip force, automatic correction function, and that's all standard and built into the system. This just gives you an idea how we monitor. We have position monitoring for power generation. We have mechatronic drives with electric motor brake. There's redundant backups for safeties. There's a brake. There's a mechanical interface, and there's an electronic interface. Even if you lose energy, you never lose grip force because it only de-energizes when it sends a signal to de-energize. So I can sense jaw position, clamping force. I get a visual component of backup. I have one control board internally, so not a lot of electronic components. I have a mechanical self-locking wedge hook, and I have a 4-time servo control, and it's a very basic setup. Just again, it's powered by an inductive coupler. The basic setup is very similar to what you see now, less the cylinder. We have a rotary union in the back, so we can still supply media if we need to, or supply the electric signal for our LPS and our electronic sensors. We have our coupler in our remote, feeds a wire through your machine tool spindle through a small tube to the coupler at the back of the chuck, sends all the power to the chuck, and you're operating without any hydraulic force. Again, that combination of these two give you the ability to have smart work holding. We've also designed a smart tool holder, a load cell for this one happened to be for friction welding. You know, the biggest challenge they've had in the past with friction welding is the ability to know axial forces. You know, radial force is radial force is very easy. Axial force is very easy. Radial force is hard to detect. This allows you to do both with a base unit, a standard tool holder, and with a componentry built into it from our electric sensors to power this unit and give you monitoring and predictable, again, IP67 protection. And last but not least is our full line of electric grippers. And when you couple this with our wireless coupling technology, gives you the ability now to get 360 degrees of rotation without the limits of clips, wires, pneumatic lines to get tangled up. I can now assemble parts with a gripper. I can now pick and place. And because these are sealed units, I can use those in clean rooms. We're also introducing a full line of fully pneumatic grippers. I'm not going to bore you. Pneumatic grippers are pneumatic grippers. We all look the same. We all make a 2-jaw and a 3-jaw setup. Ours are being delivered to the marketplace as we speak. We're going to compete in that product spectrum pretty quickly and pretty rapidly. And with that being said, that's kind of my spiel for today. I mean, there's a lot more information to be shared. Any of this information is available to anyone who would like to have it after the fact. All you have to do is send an email either through Jake or directly myself at SMW Autoblok, and we'll be happy to supply you with information and talk to you about your solution and the solution for your product.
Awesome. Well, Larry, once again, thank you very much for joining us today. It does not look like we have time for questions as we are up against it. But if anyone had a question after going through that entire presentation, I mean, I feel like you pretty much explained everything. So thank you very much, Larry.
Thanks, Jake. Thank you for your time. And again, thank you everyone for your time. And I appreciate it. Anything we can do to help our industry succeed, that's what we're here for.
You can find more Lunch and Learns plus the MFG Radio Network's other podcasts on Apple Music, Spotify, Google Podcasts, or on our websites